overview of world building. This is the one we're going to look at. So this is the whole thing. I'm going to zoom in on parts of this in a second and go over each of these sections in detail. But in general, what we've got is you got the level in the middle, so the level that's being produced, that is being built. You got the playable experience on that side, just like we saw in the earlier schematic, simplified schematic. And then you got these big boxes. So this first box we're going to look at are things that you can place in the world that aren't 3D actors. Okay, so it could be triggers, player starts, lights, anything like that. This is going to go fairly fast because a lot of this is straightforward. Then we're going to take a look at things you can place that are 3D. So models, characters, anything like that. Different types we've got there. There's some 3D tools there. We're going to very briefly touch on that at this current point. When we're recording this, these are very early in development, so we're going to go over those more briefly. We're going to take a look at things that control the level, so additional tools that help control the content that you've placed. The rebuilding process, what's involved in that. A couple of things left and right that are also impacting it. This is level streaming, this section here, and we've got some additional performance tools. And that's what we're going to go through. So if you start indeed with the placeable actors, and what I'm going to do now is I'm going to switch back and forth between the full image we have over here and the editor. Again, I'm going to do some of these really, really fast because they speak for themselves. Audio actors are the many different types of actors involved with audio. I don't have a clear example in our project, and again, it speaks for itself, and I don't want to stray into audio, so I'm going to immediately move forward. Emitter actors are particles of any kind. It might be cascade particles, which is the older system. It might be Niagara emitters, but emitters of some kind. So that's also straightforward. Reflection captures are the different kinds, and there's 3 different kinds of reflection captures. You got a sphere capture, box captures, planar captures, and those are things that in the rendering class, we're going to take a look at those as well, but just very briefly, as we start moving into world building here, this thing, for example, right here is a sphere reflection capture, right? And you can see this also here in visual effects. We've got box reflection, planar, and sphere. So those are those kind of things you would place. And then we move on. There's many different types of lights. You got directional lights. Let me show you this in the editor rather. In lights, you got directional lights, you got point lights, you got spotlights, you got rectangular lights, and you got skylights. So there's 5 different types. And each of those 5, as you look over here, can be set to static, stationary, or movable. So static is baked, movable is entirely dynamic. Stationary is some kind of hybrid between the two, where it takes, it's partially baked, it's also partially dynamic. These are all things we take a look at in the rendering class. So here too, I will move on faster. That's what we have over here. And then there are the things that are more specific. So here's where we're going to start getting a bit more details. There are volumes. And volumes in Unreal are used for pretty much everything. You look at this in the editor. There's a section called volumes. You can see I have a pretty long list here. They could be something like a trigger volume. It could be blocking volume, so invisible colliders, that's a volume. A kill Z volume, for example, would kill the player if it enters below a certain height within the volume. So there's a lot of different things there that affect the gameplay or that block the player, or for example, that change the post-processing. It alters the way the game works within that box. And so if you look at any level in Unreal, you're going to see a lot of volumes. So just around this little section over here, this thing is a volume, that thing is a volume, that thing is a volume, and they have different purposes. This is a lightness importance volume. Get back to it in a second, but it essentially gives higher quality lighting. This is pre-computer visibility covered in the rendering section class. This is a cull distance volume. We're also covering that in rendering. So there's a lot of volumes. As part of that, in turn, you have geometry editing, which you can use to modify some of this. So there's a tab here that's geometry editing. Essentially, it's very simple modeling tools, but you can use it to modify the volumes that you've placed and, just extend it a bit. But there's also an extrude option there and a few other things. So those are volumes. And then there is Blueprint. Now, in the Blueprint class, we're going to really look at this in depth. So I only want to approach it here from the perspective of how do you use Blueprint in a level, okay? And if you're, for example, a level artist or someone who's more visually oriented, you definitely shouldn't have the idea that Blueprint is something you shouldn't touch, that it's only for the scripters, the programmers, for other people. Even if you're an artist, if you're an environment artist, for example, I believe that everyone should know Blueprint, because Blueprint doesn't just come down to gameplay, because that's the obvious use of Blueprint. For example, here's some very simple examples of this. It's a simple game we've made, but this is a button, obviously. If you can look at that in the content browser, the button is over there. That is a blueprint. So we've made a self-contained little button thingy. That is a blueprint in itself. And for that, by the way, I've reused a pillar base to make it funny, because I couldn't find something that would work as a button, but it's a button, trust me. But this is the obvious use of Blueprint. It's a little, essentially almost like a prefab with an embedded script, if you want to look at it that way. So you step on the button, if it overlaps, only do it once. It plays the animation with a timeline, something we'll see in a few minutes when we discuss timelines, and then it simply sets rotation. This part is straightforward. But where Blueprint really shines, especially if you're an environment artist or someone, again, who's not focused on Blueprint, is you can do many more things with it. So I prepared a few things I gotta find back here. I think this is, for example, a blueprint that's on a spline. So here you've got a spline in there. You can edit the spline. If I manage to actually click on it, which I so far have not done. There we are. Right, so you edit the spline point, and now you can move this mesh over that spline like that. And this is very, very simple use. These examples are simple, but for example, if you got a street, you could make a spline that follows the road, and that then automatically places street lights on a set distance following the curvature of the road, that kind of stuff. So a lot of Blueprints is definitely not just about gameplay, it's also about helping you build worlds and manage your content. Because you can see that entire Blueprint script is nothing more than this. So it's not intimidating to get into.
Yeah. In the moment that you feel that you are repeating like the same structure several times, like you are placing the same object several times together with other objects, other actors, you can make that a blueprint, and you can make it already on the actors that you have been adding to the level. So just consider that.
For example, of this one, the fire pit, these things are called fire pits. So I made a blueprint called fire pit. I dragged it in there. And again, simple example, but I made an option in here that says bright glow. If I say bright glow, let me place it near a wall so you actually see the glow. It glows a bit brighter. It's a very, very simple thing. But the idea was that if you've got these sets where you can make a little blueprint out of it. I remember a game I worked on, we had a lot of bottles that were like, leftover bottles, like trash essentially, and we wanted a lot of different configurations. Or an even better one, we had candles. A lot of different configurations of candles. Because a candle might be the mesh, it might be a little light on top, it might be the particle, and so that would be annoying to do one by one, case by case. And you also wouldn't just want to group it in a prefab, you kind of want to have an option. So we made a bunch of options here that says what kind of configuration do you want, and it would combine all of that, through that blueprint, through just an option that you can change, made it very fast. And again, if you look at what's in here, this is the entire script. A lot of these things are really easy to get into. Okay, so just want to highlight the power of Blueprint for workflow and just how critical it is for many things you do in Unreal. And then there is random other things that I will move over fast. Gameplay, triggers, player starts, so the default start position of the player, spawn points, anything like that. Okay, so everything else. And there's all kinds of things we haven't covered here, by the way, decals, for example. So, but you get the idea. I think a lot of this speaks for itself. There are things you can place. When we get to the 3D ones, it gets more interesting. So there's a lot of different 3D meshes or actors, depends how you want to call it, but things that are 3D you can place. Okay. So that's that whole section over here, the whole purple box. And the most obvious one is definitely static meshes. So static meshes are the default 3D meshes that are placed in Unreal. They're static, so they do not deform or they do not move. Typically, but that's definitely not true in all cases. But that's where the name originally came from. So there's just ordinary things like this, the desk here, the chair I'm sitting on, all of that would be a static mesh. There's not much to show there. Most of the things in the world we have here are static mesh, static mesh, static mesh, static mesh, and so on. They're just.
I will add that it means that they won't have bone-based deformation.
Yes.
Yeah.
So you can do deformation on them through the vertex shader, but there's no bone-based deformation in these.
Yeah.
So that's it. That's it. So very little to say about that. It's very obvious and straightforward. But if you see static meshes, they've got a lot of arms and connections coming into it over here. I'm going to talk about this section in a bit, so I'll ignore that. But at the bottom here, we've got some more advanced features. We got H-lots. Okay, so first of all, by the way, there is regular lotting. Okay, so straightforward. This statue, for example, has lot set up and a very aggressive distance, just to illustrate it. You can see right there, that is a lot. The materials in Unreal, they automatically will do a screen door fade, so a dirter transition. I believe that is an option here, but I'm not sure. It might have been moved. Yeah, we have a dirter lot transition, so there's an option in the materials that you can enable to help smooth it out a bit. So that's automated, that's built in by default into the shaders. But we have normal lots. But where it really starts to shine, and it gets more specific, are these H-lots, hierarchical lots. And a hierarchical lot is what we've got over here. See, that statue over here is just a test, so place a little statue here. It has a very obvious transition, okay? So the transition is normally not this obvious, but for the sake of example, we made it very ugly, essentially, and visible. These are 3 different models. So a normal lot would cut down on the polygon count and the distance, and that's it. But you still have different draw calls. So what an H-lot tries to do is it combines the meshes in a distance. You can see these are 4 different things right now. And this box controls everything in here. It's going to have a H-lots generated through the H-lot tools. So it automatically generates that. It automatically figures it out. And then it would replace it. You can see the switch. I'm not sure if that's going to be very visible, but try to go full screen on this. There is a switch right there. That's, again, an ugly transition to make it obvious. Once it's switched over, it essentially replaces it with a single model, so one draw call, where it has merged it takes the original location in the world, so it's a bit far from the center here, but it cuts down the polygon count, and it merges all of the textures into one. It doesn't do it particularly sophisticated. I mean, it's a bit of a random combination of things, but for the distance, that works pretty well. So those are H-lots, and that's what we use extensively, for example, in Fortnite to handle distant geometry, and so on and so on. Now, next to that, you've got instant static meshes. The engine does automatic mesh batching anyhow, which again we get back to in rendering, but it also has the ability to do instant static meshes, which means the meshes in Unreal by default, without instant static meshes, they're always batched in memory. Okay, so the mesh is only loaded once in memory, but it's rendered multiple times as multiple draw calls. But with instant static rendering, it's also batch rendered. So, for example, I did this on these pillars, which is, by the way, not the best example, because in a real production environment, it'd be a pretty bad idea to do it for 4 pillars only. But for the sake of example, we've got these 4 pillars here. You can see there's a component called instant static mesh. And it's got 4 instances over here. And that's been set up as that. So they will render as one. That's also, by the way, what's used for the foliage, which we'll get back to in a bit. So, same idea. And there are splines. I don't have any examples here of splines, but as you can see on the image, it's going to be a bit compressed there. But essentially, you can, what do you call the term actually? Loft or revolve? Actually, it's a revolve. It's a revolve, yeah. Yeah, loft or revolve, a mesh over the spline and make, for example, pipes or railings or things like that. So that's in there as well.
Create meshes along the splines.
Yeah, essentially have the splines, the meshes follow the splines. Then you've got skeletal meshes. That one speaks for itself, so we'll get back to that in animation and character, but essentially skeletal meshes. Meshes with bones, typically used for characters, might be used for vehicles or other things as well. But for example, this enemy here, that is a skeletal mesh. You have a different color as well in the wireframe, so that helps you identify it. It's white, skeletal mesh. Again, I'll get back to that. They too can lot, obviously. Then we got geometry, which also uses the geometry editing that we've just seen. Geometry, however, is old and outdated, I would say. So use with care, and it's typically only used for prototyping or white boxing and something like that. So if I go to an empty space here, see we got the geometry tab here. You can drag in a box, and you get obviously a box. You can modify how big it is here, and you can still do the original subtracting that Unreal Engine 1 and 2 introduced. So you can have one box subtract from the other one. So that works. You can use geometry editing to do basic modeling with this. It's great for white boxing and, you know, trying things, but you do have to truly understand that this is not a normal mesh. This is a BSP, binary space partitioning, or also called CSG. This is the original system from the 90s with many different pros and cons, mostly cons, like almost only. So you really have to understand what you're doing. If it's going to do a Boolean operation between the meshes, so if you got different brushes intersecting, it's going to do the triangulation of those meshes is going to be very, very, very bad, and you're going to get a lot of errors, and you really have to understand what you're doing. So again, feel free to work with it, but do really use with care. Then there are procedural meshes. I don't have an example in the project, but it's a plugin you have to enable. So there's a plugin called, I think, Procedural Mesh Component. You got to enable that, and it allows you to generate a mesh through code, if I'm describing it correctly, right?
Yes.
Essentially, yes, right? So you can basically say vertex here, vertex there, connect this, and build up the mesh as you see fit for procedural content. And then we start getting to the outdoor sections, so essentially foliage and landscapes. So within foliage, we have three different ways of doing that. So I'm going to go down here at the bottom, and we've got the foliage tool, which is the most easy to find, the most fun to use, I think, and perhaps might you say the most powerful in a sense. So the foliage tool is located over here. We've got this, you can see we can add a different type. So currently disabled, but let me, for example, enable the trees. Wait, let me fly through some empty area over here. You know, you paint somewhere and you get trees, hooray. So you basically just place the foliage. The interesting part about Unreal Engine 4 is that when the foliage is placed, it acts as one object. It's batch rendered. But when you go into the foliage mode, you can still use select and select individual instances within there and actually modify them. If you wish, even delete them and work with them. And that's cool. There's also a lot of settings over here. I'm going to get back to that in the advice section. They can work with. The other way of working, of doing foliage, is use the grass layer in the landscape. And that works very well for essentially grass or small rock stuff that's all over the landscape. You can see we've placed some trees over here and actually some other small rocks and small plants. But if you start going out away, you know, in the distance, there's nothing more here except there's still grass. And obviously we didn't paint this by hand. That would be annoying. So this is where the grass layer comes into play. In the material of the landscape, that's the material of the landscape, that's the setup, ignore all of that. You're actually able to add another output to it, which is called grass. Now, that one, in turn, can be connected to a layer. So we have a layer called grass because one of these over here is a layer called grass. So it reads the position of where we've painted the grass texture. Where the grass texture has been painted, it then automatically applies the grass type, which is an asset that was added over here, which in turn has the mesh set. It automatically adds that with these settings. That has some advantages. Two advantages. One advantage is that it's much easier. It just automatically applies it to the whole terrain. Second advantage, and this is the most important technical one, is that it will reuse the lighting information of the landscape underneath. So these meshes don't bake their own light maps or don't figure out their lighting on their own. They simply sample the lighting as was baked or rendered on the landscape under it and use that for the grass as well. So it gets more uniform and it scales better to larger environments. Okay, and then we've got procedural foliage. This is still up and coming. At this point in time, it's more experimental. But briefly showing that as well. You might have to enable this in the project. I forgot if you have to enable it somewhere.
It is experimental.
It's, I think, yeah. At the moment, it's in editor preferences, I think even. Yeah. And then the question actually is, did we enable it on this computer when we copied it? So let's see. Yeah, so it's not even enabled here. If you do have it in a level like I do, it is still working, but it's just, it will not be exposed to the interface. So we enabled it here.
You won't be able to create new volumes of procedural.
So now you will get a volume called procedural, somewhere in here, procedural foliage volume there, and a blocking volume in that one, which is the one we see in the level here. And it allows you to, in this case, trees. It will place the trees based on this procedural foliage asset. And this one has, you know, what's in here, the mesh that's being spawned. And what it tries to do is it tries to place the meshes a bit more intelligently than just randomly scattering around. For example, it will try to make sure one tree cannot overlap with another tree, so not two trees at roughly the same place. It can try to stimulate growth. So you can see the trees are kind of grouped in little groups because it figured out if I have one tree and it seeds trees nearby, it spreads its seed, then more trees will start growing, surrounding it, and that's how forests start to spread. So it tries to simulate.
But also you can tell the foliage type that you want, for example, something growing in the shadow of those trees, or you don't want one of those foliage types growing in the shadow. So you can decide, for example, if you want mushrooms, you can have them in the shadow of the trees and that kind of things.
Yeah. So that's that one. Then we've got, again, I don't have an example of this particular one, but this is also new in the engine at this point. It's the geometry collections and connected to that chaos destructible. So chaos is a new physics system. It's our own physics system that we're moving into the engine. And it also has support for destructibles. So a geometry collection is the ability to fracture, essentially, the meshes and store that. So that's that. But then let's move back to landscapes, because we are pretty much there anyway with the foliage. So the landscape system in Unreal is it's a pretty extensive system. It's made up of different sections here. I'll briefly show you that in the editor as well. So we've got the whole landscape. You can see that's the landscape. It's also white in color. Landscape mode over here. It's got a couple of interesting things. It's, first of all, it's divided in sections. So that's what we're looking over here. See, these. Each of these is, I believe, actually a height map. I believe it's a height map in itself. Is it? Right. It's entirely a height map in itself, which means that you can remove or modify or extend these areas as you see fit. I can add something to it on the right. And I can keep going in the same way. I can say, I don't want to have this one anymore, and I can remove it. So what it allows you to do is allows you to scale the landscape to extensive sizes, because rather than having one giant height map, which is going to be a problem, because if you want to make that bigger or smaller, I mean, it's a problem. It actually extends it with these little squares that get added to it. It also allows you to have rectangular landscapes, for example, or different kind of shapes, U-shape perhaps, or anything else that you see fit. And that's a very interesting system. You got the sculpting tools, speaks for itself, but including some erosion tools, hydro erosion, noise, and so on and so on. So it's just the normal sculpting tools. You can also import that. You can import splat maps. All the normal things can be done easily. But there's also visibility. And visibility allows you to paint, as has happened under the building here. It allows you to do this. So you paint literally visibility on the landscape. It does require a masked material. So the landscape material has to be set to masked. And this doesn't just remove visibility, it also removes actually the collision. Collision is also gone. Not 100% perfect, I think, on the edges. There is a slight, slight imprecision on the sides, but it's really, really nice for building caves, and you have to go through the surface of the landscape to get underneath. You would use visibility. And there's other things. Landscape gizmos allow you to select an area of the landscape and then copy it. So essentially you mark it and then you copy the whole area and put it somewhere else. Layers is a feature that was recently added as well. When you sculpt the landscape, you can create layers here. This has to be enabled, by the way, in the properties of the landscape. But you create layers and it allows you to paint, for example, on the layer with visibility, like so. So you paint the hill there. If you hide the layer, it's off again. So you can layer the different things together. You can layer, for example, fine detail painting with the big bulgy shapes of, the general layout of the landscape. There's that. And landscape painting is just the painting of the textures and materials. And then there is some additional features there too. You got landscape splines. Remember here. So edit splines. And I got one tiny example which doesn't make any sense, but there's a road in the middle of nowhere here. So for example, that's the landscape spline. So you could be able to, you place points, you modify the points. For example, if I take the road here in the middle, I pull it up, and then I say I want to deform the landscape to fit the splines. I do like this, and the landscape immediately fits that. In this case, was a bit aggressive. It's a bit extreme, but that's a feature that's in there as well. Works well for rivers, roads, that kind of thing. And recently also added was the landmass plugin. So it's a plugin you've got to enable, and then that one in turn has landscape brushes. Just to show you in the slides what that would look like. So that's a landscape brush. So it's a blueprint. The blueprint has a spline inside, similar to the splines we've seen earlier with blueprints. And the landscape is able to read that and modify its geometry based on where the blueprint is placed. So essentially, you're able to then make a mountain, save it as a spline in a blueprint, and then put the blueprint on top of the landscape, and suddenly you've got a mountain that you can move around and blends. It's part of the landscape. It's not just a mesh on top of it. Also works the inverse for canyons or anything like that. It would work, for example, if you got a real-time strategy game and you place a building on a landscape, you could embed a blueprint in there, so the building automatically, actually it doesn't do it in real time though, I think. No, so okay, real-time strategy game, as long as you place it not in real time but in the editor, then you can have the building automatically flatten the ground under it, so it makes it easy to place new meshes and have it adapt to it. Right, and lastly here we've got skies. Now skies traditionally in Unreal Engine 3 and Unreal Engine 4 have simply been giant meshes, which is also what we have in this level. So this is the original system. The sky is nothing more than a giant sphere. Like literally, it's just a giant sphere. And if I go back to here to one of the central positions, and the sphere has a material on it. Oh, sorry, landscape. And that's it. So it's a mesh. It's this material instance and the material instance, and then the material under it. That's it. So you can do with it as you see fit. You can place all the geometry in the distance, not just one sky. You might be able to place like big towers, mountains, anything, whatever you see fit. It's all entirely 3D. If you've got clouds drifting over, you could do them entirely in 3D, performance concerns aside. But what we recently started doing as well is we introduced the new physical-based sky and atmosphere system. And it's a little bit harder to show in this level because it's entirely set up. But I'd like to just go to new level for a second and take an empty level. Just show you very, very quickly what that really means. So, sorry, actually not start with that one. If you've got visual effects, sky and atmosphere, and this is a really cool feature because it's just you click, it works and it looks cool. I love using this. A directional light and the sky and atmosphere component together, I believe what is needed. It should be needed. And then the directional light, you have to enable a property that says used for atmosphere. If you do that, you instantly get this. So it generates a gradient with the sun in there, and it recognizes the angle of the sun and automatically adjusts all the colors. So if you do Control L, it's a shortcut for controlling the sun. So you can see if I do this, it's automatically, I can control it. If you then look at the sky, you automatically this. This is just super cool how it just blends really subtly together. How the colors work. You can change the properties to change the chemical buildup of the sky, so have more, I think ozone is one of the properties that's in there. And that affects the colors. So essentially you can also simulate an alien planet or something weirder. And on top of that, which is the even cooler part, is if you add, so I've just added the mesh on top, which is really rather big, so everything got black again. Add the mesh again. This one is a bit smaller. And what I want to get to is the fact that the entire sky system is also captured to a material. So to show you, see, we got a little sphere with the material rendered on top. This is the sky. So you can combine the two workflows by rendering the sky, the sky gradient, put it in the material, and then do the, put additional effects and whatever else you want on top. So that's a very, very cool addition to the engine. So we're through the 3D, 3D meshes you can place. In terms of 3D tools, again, I'm going to do this more briefly because this is a work in progress, heavy work in progress. But we've recently added sculpting tools and modeling tools. Before, you were only able to import meshes. So typically, you import a mesh. Now we've added sculpting and modeling. Again, I'm not going to demonstrate it, but just very briefly how it looks at the moment. We've got modeling here. I've got a couple of modeling tools. more interesting and directly applicable to everyone, regardless of how you make your models, are these two over here. So the UV tools allow you to re-UV and modify the UVs in the engine. That is most commonly used, for example, for generating light map UVs. So you can have the engine just generate all the light maps for you when it imports to Mesh or later on. You also got mesh simplification, which is a standard part of the engine. It's been there for a while now. As you can see on the picture here, it's just part of every model. You're able to essentially simplify the mesh. So you can do lot generation. You can build a little utility blueprint editor scripting that generates the lots for all of your content at once, or generates it when you import it. All of it can be automated. All of it is part of the engine. And these are things that you find in any model, by the way. Static mesh editor over here. There's all kinds of things here like reduction settings, and the UV tools are somewhere in here as well. Generate UV and so on and so on. Okay. But other than that, I'm going to skip through that. Okay. Then we can move on to controlling the level, rebuilding, and then we get to the end where we talk about streaming. Sorry, I'm going to go here. Okay, so controlling levels. There's 4 tools here. We just want to highlight for a second as well. I'm going to start on the most commonly used one. Well, actually, the most commonly used one would probably be that one. The world properties, very simple. It's just a list of properties that every level has. But it's important to be aware of it because it has a number of things in there. It's nothing more than literally, as mentioned, world settings, a list of properties. It does contain stuff about light mass, which we'll see in a second, and the default game mode, which are the 2 most common things I typically change here. But just so you're aware of it. Then you have blueprint in general. Now, blueprint stands on its own, but there is a version of it that's called the level blueprint. Every level also has a blueprint that's embedded into it. And there's also a timeline there, which is one of the sub-editors that are part of blueprint, one of the most obvious ones. So over here, we got blueprint, we got level blueprint, and you can use this for any one-off scripting, any scripting that's specific to the level. As you can see, I have a couple of examples here. This changing level variance, seeing that in a second. Light scenarios, seeing that in a bit as well, and so on and so on. So every level has that. The timelines are this. So you can add a timeline to blueprint, add a timeline, and if you double-click it, you get a curve editor, which can run that animation. It's being outputted here on update. Set the rotation of this actor. So that's this is the preferred way that we do simple animation in the level. So if you got a door or an elevator, you're not meant to start doing bone skeletal animations on that. That's complete overkill. Some exceptions aside, but I think collision also gets more annoying. Yep. So you're definitely meant to make doors, elevators, buttons, levers, anything simple. That should all be just a timeline or similar. But timeline is what I would propose. Sequencer can also be used as cinematic editor. It has like a big track editor and you can animate a lot with it. But I feel that it's overkill for a lot of simple things like simple animation. That is just too much. It also just gives overhead because then you need to have the sequencer asset somewhere. Then you need to put it in the level, and I think it gets too much. So I prefer to do this because it can always be embedded in every blueprint that's there. On the downside, you can't preview it until you play. But we briefly touched on the variance. This is a new feature. I'm not sure many people are aware of at this point. It's a manager that manages variance, as the name implies, I assume. So it's an asset you make. You make an asset called the level variance set. If you double-click that, you get that editor. We made 2 sets here. In each set, you can assign a number of actors. You can add whatever you want of the world, but I selected the floor of the world we're in, and I think these arch things at the top. So that's over here. Each of those in turn can have whatever property you want assigned to it. So you can do add properties, and I can select for any of this, and I can change it. So essentially all of this is just a list of all of these things, hold this property. All of these things, hold that property. And then I can change that to blueprint and instantly have a different variation on the level. I did that here. There's a blueprint that says, as you can see over here, level variant. It's switch on variant by index, and it just switches between the 2 versions I have. If I run the game here, make sure it's turning on the sound. And we do CE, because you can always do CE. If you use a level blueprint, by the way, you can use CE, and then you can force run one of the functions or the events in there. So it's great for testing. CE level variant. Now it's green. It's also green at the top. Might be harder to see, but it's green over there, right? And that's it. So that's the level variant. Also, it hits the things on the wall, by the way, as you can see. So it can do whatever you want. Materials, visibility, etc., etc. Okay. And then there is sequencer, as mentioned. That is the larger scale track editor. It's meant for cinematics, so that is there too. But for simple things, it's overkill. For other things, it's very powerful. So I got a very basic example over here. This is a sequencer asset in a content browser. It's placed as a sequencer player in the world. That has an open level sequence button in it. You press that, you get the sequencer editor. I made a simple, and again, really the emphasis on very simple cinematic here. We can click that so the camera sticks to the viewport, and we get this. So that's sequencer. That's all my beautiful cinematic does. Isn't it nice?
Yep. It's important to know that sequencer can modify almost anything that has a value. You can key a lot of things inside sequencer, like material properties, like almost anything that you can imagine, it can be keyed and controlled in sequencer.
Yeah. Okay. Oh, and there are sequencer templates if you wish to speed up the creation of them. Then there's the active rebuilding. Now, this is not a necessary step. It really depends on what you're doing. There are cases where you want to build your worlds and levels without pre-computing anything. That totally happens, and that's totally fine. But often there is some form of pre-calculation involved. And so when the level, because all of this has now come into the level, and by the way, before we move on, just a very quick mention here, we do have multi-user editing as well. So you're able to set up a server and have multiple people edit the level at real time, basically as a multiplayer game, so you see what you're doing. That's originally, we didn't build that for, I would say, the games industry. It's more of a media and entertainment thing, you know,
Yep.
that kind of thing. So it's not super battle tested on the game end. It's not something that we typically see, you know, people do in the games industry, but nonetheless, it's there. It's very fun to play with, I think.
Yeah. The important thing is that you can modify the same exact level at the same time, but two people instead of using source control.
Yeah. But let's get to that, the rebuilding, okay, which is made up of all of these things. And you know, some of these are very straightforward. Obviously, it's going to generate light maps. It will do that entirely by itself. There's nothing you need to do that as long as the meshes have UV coordinates set up on a second channel, or not necessarily even on the second channel, right resolution, it'll handle it by itself. The engine will, by the way, generate UV maps for you as well, for light maps if you so desire, or you can do it yourself in any other program. Then there are also volumetric light maps it builds. As we'll see in rendering, actually, let's just, let's focus on that in rendering, but in the rendering class, we'll take a look at what volumetric light maps are, but they'll be spread all over the world and generated by the rebuilding process as well. Now, this is controlled by the light map importance volume. So the light map importance volume is important, as the name implies, because within that box, this is the light map importance volume, within that box you get higher quality lighting. So you're meant to place that box around those parts of the world where you're actually playing. Like not on the far distant geometry, just where you're actually playing. And that will also, you know, higher quality light, it controls where the volumetric light maps are placed, and so on, and so on. Optionally, as will also be covered in rendering, you have pre-computed visibility that could come in, but again, we'll cover it, covering that in rendering, and that makes the lighting. The H slots also have to be calculated and built. The meshes have to be generated, so that's part of the rebuilding process there. That's the interface you've seen a bit ago. The reflection captures, so all the reflections are placed, they need to be updated and captured. That happens during the light rebuilding as well, or rather during rebuilding. It should be noted that if you've got a cooked and packaged game, so in the finished game, the reflection captures are baked in. So it'll literally bake the textures, the cube maps that it generates in. In the editor, or any time before it's cooked, the reflection captures have to be regenerated all the time, either by rebuild or when you open the level. This is one of the reasons why it takes a longer amount of time to open a level that has not been cooked and packaged.
In a way, you can have those as assets in the content browser and assign them to the reflection capture, so you don't have to be doing that process. So that's optional. Really.
That works too, but then you have to manually indeed do all of that. I wouldn't say that's a common thing. I would say that's only done in very particular cases when you want really exactly this reflection.
I know. But I had a project where we had to do that. So just to mention.
And then there's the nav meshes. Again, it's all generated here. And just to show you in the editor, by the way, where this is located, there's a build menu at the top. There's a lot of different things you can build here. Build geometry we skipped, but essentially it rebuilds the geometry BSP brush. It's not really used anymore, so I skipped that. But the rest is here. And the nav mesh, you can also see. I enabled nav mesh. It's the P key on the keyboard indeed. So this is the nav mesh as has been generated by build. Where is it? Build pods.
Yep.
Yeah. Funny thing is, build pods actually is an Unreal Engine 1 term, which is still in here because it's no longer a pod. But in Unreal Engine 1, you had little lines connecting everything, so it was build pods. But that's all of that, and that is driven by light mesh, the lighting part. But we'll get back to that in rendering too. The light scenarios you could optionally use. It's not a must. A light scenario is level streaming, or the sub-levels, as you like it to be called. We had a long discussion on that yesterday. And we're going to get, this is what we're phasing into. There is a level tab, which is by default in window. You can have different levels here. Again, I'm going to show that in a second. But you can specify them as being a light scenario, which we've done with these two levels over here. So this is the daytime. The other one is called night, and it didn't end up being night. It's more like evening, but I didn't feel like renaming the level. If I hide this one and enable this, I get the same level, but with nighttime settings, or rather evening settings. So it allows you to put the lighting in sub-levels and then interchange them and have basically a different light scenario as you see fit.
The thing is, you can't interpolate between those.
No, it's a switch, and that's it. And it might give a small delay, like a tiny delay. I mean, it has to load things in there, so.
Yep.
Yeah. So. Okay. Right. Let's see where we're at. And then, therefore, we get to these different sub-levels. You don't have to use it. It's not used all the time. In fact, for the level that I have here in this example project, if we wouldn't have recorded it for this, we might very well not have used any sub-levels. But it is a very important feature for any larger production. It's basically impossible to work without. So there are three alternative ways forward. If we're located over here, you could just ignore it and not use it. That works, but it tends to, again, only work for smaller things. Or you can go this route or that route. Two completely different ways to go. This is the original intent of the system. It's to do actual streaming levels. Streaming levels as in you load something, or rather, sorry, I think it was the bottom one. Was it the bottom one, the other way around? No. Sorry, yes, this is the original intent. So streaming levels. So if you look in the editor, the hallway in the back here is a separate level called streaming level. If I hide that, the hallway is gone. Okay, so that stuff is in a different level. These things, by the way, are, find them back, physically different levels. See, these are the different levels in here. So they're really normal standard levels, but one level gets merged into another level. So that means that one person in a team could be working on this level, the other person could be working on that level, and it all gets merged together. So there's no conflict there. But when you go back to the streaming subject, when I enter a volume, and there's a volume here somewhere again. I'm trying to remember where I put it. Somewhere near the door, from what I remember. Sometimes what I do, by the way, is go in wireframe, and then normally in my own install, I have a shortcut to hide static meshes, because it tends to make it much easier to see the volumes. I think that one. This is a level streaming volume. So you can set that up. And if you step into this volume, it loads the associated level. In this case, it's associated with this one. And it basically makes it visible and loads it from the disk. So again, level streaming. And I'm going to try to show you that. If I'm standing, and you can always switch it F1, F2, etc. in Unreal. You can switch the wireframe while playing, for example. You can see the hallway is not there in the back. If I walk into the volume, which is somewhere here, see, it just brought in the hallway. So this is really interesting. If you do this in the editor, you're going to get a small amount of lag, but I believe in the package game it runs entirely async, or it's
Yes.
yeah, it's
depending on the project setting, but yes.
Yeah, so it'll go much smoother. So the editor is definitely not a benchmark for how that's going to run. So that's the level streaming, just the regular streaming. And you can do that streaming, by the way. This actually probably should have been on top, but you can do that streaming in 4 different ways. You can control it with blueprints. As you can see, there's a little blueprint function called load stream level or similar.
Or code.
Or in code, rather, right? Sorry, there's the equivalent is in code. You can see this here too. Actually, I did exactly that. Unload stream level, load stream level. So I'm switching the light scenarios using the same setup. So that works. It's really nice to script that exactly when you want it. You could do the volumes, as just seen. So you make a volume associated with a level, and if you step into it, it automatically brings it in or unloads it as well. You can set it to always be loaded. That ties into this approach, we're going to get to in a second. Or you can use world composition, which I don't have an example of, but it's a really cool feature because it does basically that. It splits the world up in these different levels, so basically different cells. So that's the level, that's the level, that's the level, right? And all of this is part of the persistent level, which is the parent level, and it offsets those sections. So you can say a position, so it offsets, and you get this overview map as well with that. It's meant for larger open worlds.
What you can do is when you're getting, you can define a distance, and when you're getting next to that level, it will automatically load it. The limitation of that is only on the X and Y axis, not on the Z. So it's not good for like vertical cities and that kind of things. But you can define, for example, a level that has to be seen from a long distance, and then you can define like distance groups, and all the levels that have to be seen from a long distance, you can put them in that group.
But to go back to this one over here, right? So the other thing you can do with this whole system is you can use it for collaboration. And that's, again, a really powerful feature. So that's exactly what we've done here. The majority of levels in here, these 2 are light scenarios. This is the streaming we've seen, but these 2 are just here for organization's sake. So game, if I hide everything else, you're going to see what's in game. This is what's in game. You can go to unlit mode, that's it. So all the gameplay actors. So the players start. There's a trigger here, there's a button here. That wall, I didn't have a wall model, so I made a giant wall thing that became the door. So that's the door, sorry. So the door, some enemies here, they're all in the game layer. So what we typically see in production is you would have game, would have maybe a lights level, there's a sound level, there is geometry level or something. You can do that, or you split it up more maybe per location, like hallway A, like central lobby or something, and you do it per location. And within the location, all the gameplay, all the light, everything is contained within that. But it's this little pocket. That works too.
Yep.
But that really helps the team, because then you can collaborate together. You can have, the gameplay scripter can be working on the game layer, essentially, basically a layer level. The environment artist on the geometry or something, and that's really, really, really cool.
And the sound engineer will be working on the sound.
That's typically what we see, and then these would be set to always loaded. So to the player, there's zero difference. Just for the when working in the editor. Okay, and that concludes streaming, and we're basically almost there then. So we are now at the playable experience. There is a runtime NavMesh component that is existing in Unreal as well. So in case you do not want to pre-calculate the NavMesh, which sometimes is not possible, or you have a very, very large world and it wouldn't be ideal to have a giant NavMesh, you just want to generate it, you are able to generate the NavMesh at runtime around certain actors that have been marked to do so. So the enemies will have a local little NavMesh generator around them as they go through the world. But we're here to talk about performance. So there's stats. This is the original system that Unreal Engine, which one started? I think Unreal Engine 2 started that, if I remember correctly. The stats are nothing more than just things displayed on screen with numbers that you can read, and then you have an idea of what happens. So there's actually a long, long list in this drop-down menu in the viewport. Stats, you got lots of stuff. Okay, I typically only use a few of these, and I typically type them because they all have commands just as well. So for example, stat scene rendering, which isn't even suggested, by the way, so some of these are not easy to find. you get this. And this is basically the rendering of the scene. Gives you a summary of it. It's not particularly precise, but you have an idea of the mesh draw calls. How many draw calls do we have? How many lights are in the scene? For example, there's a start there. Decals in view. There's 2 decals in view. The render. The overall render time here is 11 milliseconds at the moment, average. So you get a nice idea as you walk around in real time what all of this is. You've got many other things. For example, if you type stat none, by the way, you hide whatever stats you had open because you're going to have lots and lots of them at some point. Stat game shows you, when we get to it for blueprint, but it would show you the blueprint time. There's a lot of that. Stat physics, I believe, still exists. Yeah, there's things there. So you can go through the stat commands, but it's really nice to get a quick idea of where you're at.
Stat unit and a stat
FPS.
right,
sorry, yeah, absolutely, yeah. So the most critical ones are stat FPS, which is the frame rate. And there is a stat unit, which is showing that as well, the millisecond, but divided per thread. So game draw and GPU, which is the frame time. So then you can figure out if you're bottlenecked by the CPU or the GPU, and then that in turn gives you an idea where to look. If it's physics, it's going to be on the CPU, so then, gives you a direction. Again, stat none kills everything. There's also a setting somewhere in the project, I think project settings, by the way, that allows you to keep open whatever stats you had on the screen when you restart the project. So then you don't have to type this stuff every time you start the game or the editor. There's a GPU profiler, which is a built-in visual profile of more or less the same information, but collected together and easier to read probably. I think it's default Control-Shift, comma, if I recall. There's also command, I think, profile GPU or GPU profile. I keep mixing the direction up. But this is the GPU visualizer, so it's the same thing. It gives you a visual representation of the expense, of the milliseconds here, and as you go through. So this is a snapshot, very important notice, not real time. So this is just this very moment I pressed that button. So that's that. There is the statistics panels. A little bit forgotten, I feel, but really nice feature. Window statistics. It's just a table-style listing of everything in the world for primitive, texture stats, and also for the lighting. So you can see, for example, if you look at textures, how many textures we've got in here, like the resolution of them. We can sort by resolution, so we can quickly figure out, okay, there's 4 meshes in here with an 8192 texture. Probably that's a bad idea. So you get a quick idea of, and you can see uses, for example. So if you find that mesh here, it says it's only used once. It's not necessarily always precise because that's actually the bush that's used outside. That is part of the foliage. So it's not counting the foliage instances, just counts foliage as one. It's not always precise, but it gives very good ideas of where we're at. With everything, again, primitive stats, you see everything. The number of meshes, the number of triangles, the triangles combined, the vertex colors for VC here, the light map cost, the size of the mesh in memory, everything. So it's really nice. And you can select by it, which is a point we have to get back to in advice. Good. Then you've got different view modes. I'm sure you probably already found these if you've been looking around in Unreal. Many different kinds. Essentially, it means view modes here. Optimization view modes, for example, you can do shader complexity. It's going to come up in a second. It's compiling shaders for the shader complexity. And you can look around and experiment a bit with these, but they're very nice to get a feeling where you're at in terms of potential issues. And then there's some additional ones. We're covering this in the rendering section, so leave that be. Make sure you look at the rendering class there as well. But it removes meshes at a distance, so it's just distance culling, but controlled with volumes. And scalability we'll also get back to it's a thing we're covering extensively in rendering, but it's a general scalability of the engine. That comes down to distance multipliers, it comes down to lots, render quality. Unreal actually has, I believe we're at 1,183, I think was the last number that I looked at, different r.scalability CVARs that allow you to change the quality of the renderer in real time as the game is running, and all of those can be set to whatever you want, so you have complete control. So that is scalability. And then there's world detail, which again I feel is very forgotten. I think that came in Unreal Engine 1 even, or Unreal Engine 2. It's still there, but it feels a little bit like everyone has moved on, which is a bit of a shame. I really like this feature. So what this one does is that in the properties of anything that's visual, so particles, meshes, anything that's rendered as a thing, there's a property in here that is called, actually find it back, I think detail mode, and you just set it to low, medium, high. Essentially, it means that if you're setting the detail mode, which is also just a command that you can run as part of the settings, to high, then the meshes that have been set to high, I believe, are removed. It's the other way around, slightly confusing. So I usually do this for small stuff. Spider webs are kind of heavy for performance because they're translucent and they're completely useless. It's just nice to look at. So I would set all of them to high. I would set smoke particles to high. I would set small embers to medium maybe. And so you can layer that away as you run the game on different platforms or different kind of computers. So, and that concludes that.
One thing regarding wall composition is that also also related to performance is that with wall composition, you can also do lots for the whole level. And it will manage also that. So it doesn't not only manage that, but also creates new levels with lower quality from your big chunk that you already
so
created.
the distance cells are basically a simplified version of the level generated by the system in turn.
Yes.
And also in turn, the landscape itself, the landscape itself at all times, actually, and it's a little bit hard to see it right now, but
well, if you go to wireframe mode, you will be the loading probably.
Not only that, I've been painting a bit. I mean, the lighting got a little bit messed up here, so ignore that. But the point is, you can see it has detail in there still. It also has detail in there because I did something to the material just as a trick. But the engine actually bakes the shape of a landscape down to a normal map, then renders a normal map on top of it, even if the landscape is greatly simplified. And it also has this automatic lot simplification, but we're getting back to that in advice. So it does a lot of stuff by itself.
Yes.